All right, good evening, everyone, and welcome to the 24th annual Barnegat Bay Environmental Educators Roundtable. My name is Becky LeBoy. I'm the Education Outreach Specialist with the Ocean County Soil Conservation District. The district has been effectively coordinating and implementing the Barnegat Bay Environmental Educators Roundtable since 1997. The Roundtable provides professional development opportunities for both school teachers and informal environmental educators. And the theme for this year's Roundtable is Inspiration for a Jersey-Friendly Schoolyard. The Barnegat Bay Watershed is a great place to live, learn, work, and play. And it's up to all of us to keep our soil, water, and other natural resources clean and maintain healthy habitat for wildlife. A Jersey-friendly schoolyard can offer an inspirational space for teaching and learning about natural resources and the direct impact that human behaviors have on the health of our community. Last week, my colleague, Karen Walzer, Public Outreach Coordinator with the Barnegat Bay Partnership, and I presented the first webinar in our series of 3 called Planning a Jersey-Friendly Schoolyard. And if you missed this program, you can find it on the Ocean County Soil Conservation District YouTube channel. And I'm here tonight with my colleague, Caitlin Gannon, Education Coordinator for Jacques Cousteau National Estuarine Research Reserve, who will be presenting her program called Why Jersey-Friendly Schoolyards? Understanding the Effects of Fertilizers on Eutrophication and Coastal Acidification. And this is the second webinar in our Roundtable series of 3. And next week, please join us on Wednesday, April 28th at 4:30 p.m. for our third and final webinar in our Barnegat Bay Environmental Educators Roundtable series, when Dr. Steve Yerjo of Rutgers Cooperative Extension will be presenting How Does Your Rain Garden Grow? And if you have any questions this evening for Caitlin, please enter them in the chat area. I will be monitoring the questions and sharing them with Caitlin at appropriate times. So Caitlin, thank you so much for joining me tonight and presenting your program, Why Jersey-Friendly Schoolyards? Understanding the Effects of Fertilizers on Eutrophication and Coastal Acidification. Thank you, Caitlin.
Oh, sure. Thanks so much, Becky, for having me today. Welcome, everybody. Once again, my name is Caitlin Gannon. I'm the Education Coordinator at the Jacques Cousteau National Estuarine Research Reserve, or JC-NER for short. Like Becky mentioned, we're going to discuss effects on fertilizers, of fertilizers on eutrophication and coastal acidification. So we'll just hop right in. Before we get into that, though, we always like to do an introduction of the Cousteau Reserve and of the National Estuarine Research Reserves, the system of the reserves. And here in this map, you can see we are a network of 30 reserves all across the country. And we are all funded by NOAA, the National Oceanic and Atmospheric Administration. So we have our operation funds coming from the federal government, but then we're all managed by a different state entity. And here in New Jersey, we're lucky enough to be managed by Rutgers University. So it's a really kind of neat state and federal partnership. And all of the circles that you see are all where we have a National Estuarine Research Reserve. So it's pretty cool. Before we get into also our discussion, I always like to review the difference between estuaries and watersheds. They are different, but they do relate to one another. So we'll start with estuaries. In the chat box, if you'd like to take a stab at defining what an estuary is in your own words, go right ahead and put that in the chat box if you'd like to. So once again, what is an estuary in your own words? Also, you can give an example of an estuary if you'd like to, if that's something you'd rather do instead. We'll just give a couple of seconds. All right, no takers. That's okay. So you might have heard of the term estuary or estuarine, and many folks will say that an estuary is where rivers meet the ocean. And that is true. Often we have estuaries, are the areas where a freshwater river will meet the salty ocean or the sea. But that isn't, I guess, the overall definition, because we actually do have, if I go back, oops, wrong way. In our map of National Estuarine Research Reserves, we have two freshwater estuaries. We have one in Ohio and then one in Wisconsin near the Great Lakes. And that's freshwater running into freshwater. So there are such thing as freshwater estuaries. And so a more encompassing definition, or a more accurate definition, is an estuary is where you have two different bodies of water that are both physically and chemically different, meeting and mixing. So we like to think of estuaries as an area where it's very dynamic. There's a lot of things going on, a lot of mixing, a lot of nutrient movement, a lot of flow. So it doesn't all have to be freshwater into the sea, but there are definitely many, many coastal estuaries and what we kind of tend to think about when we think of estuaries. And so here's our estuary at the Jacques Cousteau Reserve. It's the Mullica River meeting the ocean here in the Great Bay Area. And then we think of watersheds. So if we zoom out from the estuary, here's our estuary down here. And then we look at the entire watershed. So I'm sure you're familiar with what watersheds are. It's an area of land that kind of acts like a catch basin of precipitation when we have snow or rain. And how does that water flow? Where does that water flow down into? What streams, rivers, lakes, or other bodies of water does it eventually flow down into? And depending on the shape of the land, we divide our state, we divide the country up into different watersheds. So we all live in a watershed in some form or another. So here is the Mullica River Great Bay watershed on the right. What's really interesting, watersheds are sort of hard to picture at times. Here's a really good example of where you can, no matter where you stand, you can probably see the entire watershed. The Heia near in Hawaii, that's our Hawaii Reserve. Because of the mountains and the elevation, you can be standing at any one point in the watershed and you can see the entire watershed. It's so cool. It's one of the few watersheds where you can get the full picture. You know, New Jersey's pretty flat, so it's sometimes hard to picture the full watershed. But back to New Jersey. So the Jacques Cousteau Reserve is actually within two watersheds. Most of it is in the Mullica River watershed, but also part of it, the northern portion's in the Barnegat Bay watershed up to the north. We also span between three different counties, Burlington, Ocean, and Atlantic. The total of the JC near boundaries is about 116,000 acres. And much of the reserve is also within the Pinelands National Reserve. We are named after Jacques Cousteau. At the time of our designation in 1997, a congressman at the time wanted to name the reserve after him because that was also the same year that Jacques Cousteau had passed away. So a huge function and important ecosystem service of estuaries is that they improve water quality. But how do they actually do that? So what they do is that they will filter a lot of runoff water. So you looked at that photo of a watershed a couple of slides ago, and we have runoff from the watershed that goes into the estuary, goes into the bay, eventually goes into the ocean. It all travels down. And what estuaries do is they filter that runoff water as it flows through. And they do this in a couple of different ways. One is that they do this through a process called transpiration. So the vegetation, through a natural process, will just absorb through the roots and the stems and the leaves water, but also maybe some non-point source pollution or other impurities in that runoff water along with it. You may have done this experiment with your students where you take a piece of celery, a celery stalk, you pop it in a cup of colored water using just food coloring, and you can actually see the the green or the blue or red water travel up the stalk. So it will filter runoff water that way, but it also acts as a barrier. The vegetation that's within the estuary will literally slow the flow of water as it travels through. So the more vegetation you have, the more the water is going to flow. And then as it slows down, things in that water, either sediment or non-point source pollution, other toxins, will settle out and settle down. Then that water will continue to flow into streams and nearby rivers and the bay. And so here's another really neat experiment of an area with a lot of vegetation, with some and with none, and you can see the difference in the water quality in each of them. It gets a little worse the less vegetation you have. So we're going to do a fun activity online. Let me just copy and paste the link into the chat here. I think I can send this to everybody, all attendees. And this is a really great simulation of how estuaries act as filters. So I'm gonna have you guys go ahead and click on that link, and it will take you step by step. Just click the next button as you go. There is no audio with this clip, but then it has a couple of questions at the end. So it's kind of a fun online activity you can do with your students. Don't see the link. Oh, I sent it to all attendees. Oh no. Let me try again. Maybe I can send it to also the host. Okay, there you go, Becky. I sent it to all attendees and the host/panelists. So I think I have to send it to both of those when I do that. If you do not see the link in the chat, please let me know and I will try to see if I can send it differently. If you do have it though, go for it, click on it and give it a try. I'll give you guys a couple of minutes. should be wrapping up, maybe with the pollution game. You can do the beginner, intermediate, and advanced questions in that. If you still need a little bit more time, you can put something in the chat. Otherwise, we can keep moving forward just for the sake of time. Okay. And so if you are still doing the pollution game, that's fine. We'll just move on to the next slide about fertilizing less and how this is Jersey Friendly Yards Step 4. And this is what it's all about in this presentation here. You know, our activities that we do at home and in our school, you know, it doesn't just stay there. It can move throughout the watershed and impact our estuaries. And it can be in the form of loose soil or sediment if we have a lot of construction zones and we have that loose soil, motor oil, waste from animals, pesticides, but also the application of excess fertilizers can cause eutrophication, which can lead to a lot of issues, including coastal acidification. But the good news is that you can take action and prevent these things from entering into our waterways that we like to utilize and enjoy. So what is eutrophication? We're going to watch this video that will explain it. Hopefully the sound will be good on your end. If not, I can always give you the link to this too to watch at another time.
Eutrophication is a process that can happen in a water body, like a river or lake, when too many nutrients are added to the system. Eutrophication starts when fertilizers, which are rich in nutrients like nitrate and phosphate, are washed into the river or lake system. This leads to an increase in nutrient concentrations in the water. The nutrients are food for algae. The algae grow and reproduce quickly, forming a thick green bloom in the water. This algal bloom will absorb sunlight shining on the water, so the sunlight can't reach the bottom. Plants who need this light to photosynthesize die. The algae will also start to die when they eat up all of the nutrients and run out of food. Next, bacteria start to break down the dead plants and algae, and that releases more nutrients back into the water, continuing the algal bloom cycle. The bacteria, with a continuing supply of food, reproduce into much larger numbers, consuming oxygen as they grow and respire. There's not much oxygen in the water to begin with, so when the bacteria consume it quickly, it might run out completely. Water without oxygen is called anoxic. If the water turns anoxic, all non-bacterial life in the water, including fish and other animals, die. So, eutrophication happens when nutrients are added to water, which causes an algal bloom, cutting off sunlight and feeding bacteria. The bacteria use up oxygen in the water, which becomes anoxic, causing everything living in the water to die. Eutrophication is one reason why we need to be careful with fertilizers when we're growing crops.
All right. That's one of my favorite videos to understand, or as an introduction into eutrophication. And again, it comes from those excess nutrients from fertilizers, nitrogen and phosphorus in particular. And it has this chain reaction that occurs. You know, estuaries are really good at filtering, but sometimes if we use too much of something, it will overwhelm the estuaries and they can't filter everything out. And then eutrophication can occur in our bays. Oops, didn't mean to do that. There we go. Another really great simulation of eutrophication and a video of it is one from the NOAA Ocean Service, which is another really, really great video. And I can put all the links. I have all the links in the chat. Oh, I'm sorry, at the very end. So let me actually just go back though, and I can put this one in there too. Feel like I have it. Oh no, I just have it embedded in the PowerPoint. But I can probably get that at the end, Becky, if that's okay. So this one also, again, is really great. Ocean Service through NOAA has another very good video about how eutrophication occurs. So again, because we have those increase in nutrients, phosphorus and nitrogen that come from fertilizers, the algae love it, they eat it up, they bloom, they go crazy, and then they all die. But because of the bloom as well, subaquatic vegetation, or SAVs, don't get the sunlight that they need because the water becomes cloudy, becomes turbid. And also that turbid water is not good for the gills of the critters that live in the water too. And then the bacteria start to feed off of all of the dead plant matter, the dead algae, and that decomposition process will lower oxygen levels. And when we have lower oxygen levels, that can also be very, very harmful for the fish and other critters, especially ones that are very sensitive to low dissolved oxygen, especially certain kinds of fish. So sometimes we look for bioindicators or certain critters in waterways that do have high or low tolerance to oxygen or pollutants, and see based on what critters are present what's going on with the water, the health of the water. But also that decomposition process can release CO2 into the water as well. And release in CO2 from decomposition means potentially we can have a lower pH or an increase in acidity of our waters, causing coastal acidification. Now, because the threat of eutrophication, is always imminent and always around, especially in the springtime when people are going back to gardening. Because it can have so many issues associated with eutrophication, the Barnegat Bay Partnership and the Jacques Cousteau Reserve both have water quality monitoring programs. So the Barnegat Bay Partnership has water quality stations set up throughout their watershed in different towns: Seaside Park, Maniloking, and Morrison's Marina in Beach Haven. And every 15 minutes, they monitor water temperature, salinity, dissolved oxygen, turbidity, and pH. You can download their data at njdup.rutgers.edu/continuous if you are interested in downloading their data. And then the JC NEAR has a very similar program called the System-Wide Monitoring Program, also known as SWAMP. And much like the Barnegat Bay Partnership, we also monitor water quality every 15 minutes. We are collecting data with our instruments that are out in the bay, but we also collect data on weather and nutrient data. And that nutrient data can be chlorophyll content, phosphorus, nitrogen, ammonia, things like that. And you can also access this data. It's available to the public through nearsdata.org. And I'm going to do a quick demo real fast on the System-Wide Monitoring Program website, so you get a feel of how to use it if you do decide to use it in your teaching. So 1 second. Okay. So hopefully you can see my screen okay. This is the National Estuarine Research Reserve System SWAMP website. Again, it's nearsdata.org. And this website is used, it can be used by teachers, it can be used by visiting researchers, it can be used by aquaculture or oyster farmers who are really concerned or really interested about the quality of the water and in the bay. So if you do ever want to check it out, you can just go to nearsdata.org, click on View Download Data, and then there's what I like to use. I like to sometimes check out the real-time data. which shows you what's going on. And these are all water quality stations at each of the reserves around the country. So we have some from Florida, some from the Hudson River. Here's one from the Jacques Cousteau Reserve. You can also switch from metric to English if you like. And this is what's been going on over the last 24 hours or so in water temperature at this particular station, which is right in Great Bay. It gives you the temperature that's happening right now and salinity that's right now, dissolved oxygen, the depth, pH, and turbidity. And you can see the graphs from the last 24 hours, which is pretty neat. Kind of goes up and down with the tides most of the time, especially our salinity and depth. You can exit out of that. You can also look at weather data. So what's the air temperature like right now? It's about 52 degrees Fahrenheit, you know, up and down with daytime, and then it started to get really warm, and then we had all those thunderstorms just now, and then temperature really dropped with that cold front that just came through. So that's kind of cool to see that that just happened in the data. And we have wind speed, wind direction, precipitation, total PAR, which stands for photosynthetic active radiation. It basically means sunlight intensity. And you can look at all of those graphs within the last 24 hours as well. So that's our real-time data. Now if I go back and I maybe want to make a graph, I can go to their graphing part of the website. And then here's a map of all the reserves around the country, just like we talked about in the beginning. But I'm interested in the Jacques Cousteau Reserve, so I'm going to click on the one in New Jersey. Oops. Loading, there we go. And here are all of our water quality monitoring stations that we have throughout the estuary. We have one that's really high upriver, almost, you know, to where it's pretty fresh water. One a little bit further down, and then we have a couple out in the bay where it's very salty. But let's see, I'd like to do buoy 126, which is this one right here, out in the bay. I'm going to click on that one. And it also gave me real-time data from the last 24 hours, again, like we just saw. But I want to create a graph, a different graph. So I'm going to click on this. It says graph data. And then I'm going to select my parameters. So what do I really want to look at? I'm interested in, let's see, depth. And I'm going to pick some dates here. I'm going to go all the way back to 2012. And then you have something to compare it to. So I can compare this water quality parameter in this time frame to maybe the New York Reserve, the Delaware Reserve, maybe the one in Alaska even, but I'm going to still pick Jacques Cousteau. And then I'm going to pick the same water quality station. And then I want to compare it to pH. So I'm comparing depth and pH. And I'm going to do this around about maybe a week's worth. Maybe actually we're going to go into November a little bit. Maybe like November 2nd. All right. So a bunch of days. A little bit over a week or so. I take a little bit of time to generate the graph. The more you ask it to do, especially with like the longer amount of time, like if you picked like a couple of months, the longer it might take. So here you go, you can see the blue is our depth, water depth, the green is our pH. At this particular station, this water quality station, is at the same one, buoy 126 at the Jacques Cousteau Reserve. And we see it going up and down, obviously because of tides. And then our pH, sometimes it'll go up, sometimes it'll go down with the tides. And then all of a sudden our depth gets really, really high, about 5 meters or so. We can switch to English too if you like to, or you can keep it at metric. Either one's fine. Oops, I forgot to click graph. But we're going to switch it to English just for now. Give it a second again. Okay. All right, so we have it in feet, about 17 feet of water. That's pretty high, pretty high depth. And then our pH is affected immediately after that high water event. So it goes all the way down and then kind of goes up and down, up and down, up and down after that. So if you were noticing the dates I was choosing, this is around the time, about a week or a little over, of Superstorm Sandy, when we have very high storm surge, as you can see here. And then so all that water came into the estuary and then it all flowed out. And when it all flowed out, our pH dropped by a lot in this particular part of the bay. It actually got fairly acidic, maybe not below 7, but almost below 7, almost to 6. I would say probably stopped about at around 7, a pH of 7. But it's just really interesting to see how these things, these different water quality parameters, they kind of tell a story, especially when we have weather events or other things that are going to change the values of our water quality, like eutrophication, like storms, even if we have other celestial events, like we had, you can see in the data, the eclipse that we had a bunch of years ago in 2017. So the data and these events that we experience can really be great educational tools. And the SWAMP program and the SWAMP data that you can access definitely is a very good teaching tool when explaining and interpreting data. But it's just kind of a neat example to see how pH is affected after some storm surge, and not just, eutrophication. Here at the JC near, especially in our particular watershed, we have the pine barrens, we have trees, and especially pines and oaks that have tannins, and it contains tannins which leach into the waters. So when we do have a lot of storm surge or a lot of precipitation within our particular watershed at the Cousteau Reserve, it's pretty normal to see a low pH because of the acidity of the pine barrens. So that's actually somewhat normal and kind of cool. All right, so I'm going to stop sharing this. So I just wanted to have it as an introduction to the system-wide monitoring program if you're ever curious about using it as a teaching tool in the future. Keep moving on. And again, here are those water quality stations we have within the Barnegat Bay Partnership. They monitor the Barnegat Bay watershed, so they have their stations in the yellow stars here in the central New Jersey region. And then we have the Cousteau Reserve right below the Barnegat Bay watershed. So kind of down here in this map, and then if you look over here, this is our stations. The stations that we were looking at in the data was buoy 126, right at the mouth of the inlet here. So this gets a lot of, of salt. This is pretty salty water right here. But then we have some that go pretty far upriver too, where it's almost fresh. And then the pink dot is our weather station. So not water quality here. It's mostly, that's where we collect the weather data. So, so we looked at some pH graphs in SWAMP, and our pH can change within along the coast like we talked about, with weather conditions, but also because of our actions that we are doing on land. What do you think of when you think of acidification? I know for me, I normally think of ocean acidification and absorption of CO2 from the atmosphere affecting the ocean. But we also need to look at and think about what we're doing on land is affecting our coast and actually changing the acidity of our coastline based on the actions that we're doing in our schoolyards and in our own yards at home. So again, I mean, the bacteria feed on that algae as part of the decomposition process. After the algae feed off of all of those nutrients from fertilizers, and then as part of also the decomposition process, they're releasing CO2 into the water directly. So not coming from the atmosphere, but coming from decomposition. Okay, so the next activity is another online simulation. Put it in here to first the attendees. It looks like I had to send it separately to attendees and then separately to panelists. So I'm going to do that. And so after you click on that link, and you can go ahead and click on it right now, it's going to take you to a really neat ocean acidification story map developed by NOAA. And it goes all into ocean acidification, but one of the levels, it's called level 3, talks about specifically human activity and changing the coastline due to human activity. We're going to look at the animation. There's some really great information on the side if you scroll down, but you don't have to do that right now. We're just going to look at this animation. It does have audio for this one. So just click the start button when you're ready and it will guide you through the activity. Again, I'll give about 5 minutes and then we'll come back and wrap up. So I'll start my timer, give everybody 5 minutes. Okay, I think the simulation is probably about done for you guys. I was doing it myself, and I kind of ended around this time too. So again, another really great visual, really good interaction. You get to pick the different sources of non-point source pollution that can contribute to higher levels of CO2 in our waterways, and see what it's doing to the coast. So it really another really good tool, another really good online tool, especially if you're doing remote learning, hybrid teaching. I hope this and the other simulation that we did earlier with estuaries as being filters can help you guys out. Okay, so we'll move on. If you do want to take the conversation a little bit further, you can discuss the process of why acidification is occurring and go into a little bit of chemistry with your students as well. So this is a really good diagram from the College of Biological Sciences at UC Davis that explains that carbon dioxide plus water creates carbonic acid. So we're getting a little bit more acidic, and then carbonic acid will produce bicarbonate ions and hydrogen ions, and then from there, carbonate ions and another hydrogen ion. And pH stands for potential of hydrogen. The more hydrogen ions you have in a solution or in water, the more acidic it's going to be. So these hydrogen ions are what causing acidification in our waterways. And hydrogen ions also like to bond with those carbonate ions, and they don't, then those are locked in. And those bicarbonates are really not useful to organisms. And especially critters that have calcified shells, they need carbonate to build their shell. And calcium and carbonate, they help in the shell building process of clams, oysters, all of our shellfish critters, our bivalves, our univalves that we eat. And they can't if carbonate ions are being locked in with hydrogen ions. They're very attracted to each other, and so then the calcium feels left out, and then they can't build their shells. So it's a really it's an ecosystem impact and an economic impact. Shellfish need their shells to grow in order to provide ecosystem services for us. Oysters especially are great at filtering waters themselves. One single oyster can filter up to 50 gallons of water per day. And if they're not able to build their shell properly, then they can't perform, that ecosystem service for us. We also love to eat oysters, so it's an economic impact for oysters and other shellfish if they're not developing properly. We have a lot of oyster farmers in the area in southern New Jersey. Clamming is important, scallops are important, so it impacts them, as well as certain species of plankton that are on the base of the food chain. And so, this topic of using less fertilizer to reduce the chances of coastal acidification occurring is really important in our Jersey-friendly yard lessons, our watershed lessons, and also our ocean acidification lessons. You can kind of talk about this in any three of those subject areas. I have a favorite ocean acidification lesson from our friends at the New Jersey Sea Grant Consortium, and it explains how ocean acidification not just occurs, but inhibits shell building, and they do this with Legos. So it's a Lego activity. Kids put their hands in the bag, they grab Legos, and they put the Legos together, acting as chemistry or as molecules, and doing the chemical reaction with Legos. It's really fun. So that's a lesson that I have the link for right here, I believe. I don't know if I have it in my notes section here, but I do have it at the end of the PowerPoint if you are interested in checking that out. And again, it all starts here with what to do in the Fertilize Less part of the Jersey Friendly Yards website, and tips on, you know, what you can do instead of using fertilizers, or maybe how to use less fertilizers, what time of the year maybe is best or not best to use fertilizers, you know, things like adding compost or using slow release fertilizers, using organic mulch. These are all good alternatives to do instead of using those fertilizers that we like to use to get that perfect green lawn, or to get those flowers in our yard or anything like that. These are all really good tips and tricks and tools to use on the Jersey Friendly Yards website. And if you click on step 4, Fertilize Less, it'll explain all the steps that you can do to make sure that we have a reduction in our non-point source pollution, a reduction in nutrients entering our waterways. All right, and that's a wrap for me. Here are those links to websites. I can put them in the chat box for you if you want a specific one. Whoops, the other way. That interactive coastal acidification activity with NOAA, and then we have the Jersey Friendly Yards website, the swamp website, that website also for downloading the continuous data from the Barnegat Bay Partnership, estuary education as well. That's through the NEARS and NOAA. You can look at their great lessons, and also that's where you can get the estuaries as filters simulation. That's the first one that we did. But then also I'll look into the New Jersey Sea Grant activity for you guys too. I realized I did not put that up here. And while I find that, I'll take any questions. And thanks again so much for having me. Becky, thanks for inviting me. I had a lot of fun. And if there are any questions, I'll take them now.
Caitlin, I thought that was wonderful.
Oh, great.
Thank you so much for sharing all of those wonderful resources. I can't wait to dive in deeper to the Understanding Ocean and Coastal Acidification module, you know, beyond level 3, to kind of go through all the different tabs, all the different chapters.
Absolutely.
That's a great place.
And then I'm just putting the lesson from New Jersey Sea Grant in there. That's the Lego game. That's so cool, and I tell everybody about. They did a really great job at Sea Grant putting that one together. But yeah, I don't know. I haven't seen anything in the chat so far. But we can wait another couple of minutes if anyone has anything else if they want to type in there.
Great. Well, thank you so much, Caitlin.
Oh, yeah.
For sharing this program. It's really a great addition to the whole Jersey Friendly Yards initiative. So this program will be recorded and available on the Ocean County Soil Conservation District YouTube channel. And thanks everybody for coming tonight. We appreciate it. Don't forget to tune in next week as well on April 28th, Wednesday, April 28th at 4:30 p.m. for our third and final webinar as part of the Environmental Educators Roundtable this year with Dr. Steve Virgio of Rutgers Cooperative Extension, and he will be presenting How Does Your Jersey-Friendly Rain Garden Grow?